Hello, this video is about one of the steps in semiconductor manufacturing process. The semiconductor materials available are silicon, germanium, gallium arsenide, out of which silicon is the widely used semiconductor material because the first and the main reason, silicon and silicon dioxide interface is an ideal interface. Second, the raw material for silicon is sand and is available in plenty. Third, there are very advanced and refined techniques available to obtain very pure silicon. And the fourth, silicon can withstand very high temperatures. This video contains preparation of pure silicon from sand. The silicon obtained here is polycrystalline in the first step. To obtain a crystalline silicon, we will see the next preparation of ingot by CZ process. And at the last, you all will tell me why is silicon the preferred semiconductor material, which I have just explained it now. So let us begin with preparation of pure silicon. Sand is the raw material which has silicon in it. Sand is also called as quartzite. Its chemical composition is SiO2. In a furnace at 2000 degrees centigrade, quartzite reacts with carbon to produce silicon. The silicon obtained here has metallic impurities, many metallic impurities, mostly iron and aluminium. Hence it is called as metallurgical graded silicon. The silicon required to fabricate semiconductor devices should be extremely pure. So to remove these metallic impurities, a second reaction is undergone. This metallurgical graded silicon reacts with hydrochlorine gas, forming compounds of silicon. The compounds of silicon formed are silane, dichlorosilane, trichlorosilane, silicon tetrachloride, out of which trichlorosilane is in a liquid form at room temperatures. So this trichlorosilane is separated out from the other silicon compounds by using fractional distillation method. Now this trichlorosilane is free from metallic impurities. To obtain pure silicon, a third reaction is carried out. To obtain silicon, the final process step is chemical vapor deposition step. This trichlorosilane is converted into gas. It reacts with hydrogen, and this reaction takes place in a chamber which already has a very thin silicon rod placed. So when the trichlorosilane gas reacts with hydrogen, it releases silicon atoms, and these silicon atoms go and deposit on that silicon rod which is already present in the chamber. This silicon obtained is extremely pure, hence it is called as electronically graded silicon, the one which is useful to manufacture semiconductor devices. The purity of silicon obtained here is 99.9 times 9% pure. But the silicon obtained here is polycrystalline in nature. To manufacture semiconductor devices, we need crystalline silicon. So to obtain crystalline silicon, the next process is undergone, which is called as CZ process or Czochralski process, named after the scientist who found it out. In this CZ process, there is a chamber which is filled with an inert gas. In it there is a quartz crucible, and in this quartz crucible the electronically graded silicon is placed. The quartz crucible is surrounded by RF heater. The temperature of this heater is above 1500 degrees centigrade. That's above the melting point of silicon. So these heaters melt the electronically graded silicon. The other assembly you can see is the seed holder, which has a seed attached to it. What is a seed? A seed is an artificially grown silicon crystal in a pure form. This seed has the required plane orientation as well as a crystalline orientation. So this seed is placed in the seed holder, and this seed holder is slowly dipped in the melt. The point where the seed is dipped, the tip of the seed melts, and at the same time the surrounding melt starts to freeze. That is with the process of natural convection. Now as the melt freezes, the seed holder is slowly pulled up. While it is pulled up, it is also slowly rotated. So you can see from the melt a solid silicon crystal starts coming up. Now when the melt solidifies, the solid acquires the atomic arrangement of the seed. Correct? So gradually this seed is pulled up till the whole of the melt has been solidified. Now whatever you see here, it is named as growing crystal. We also call it as an ingot. And the ingot that we have obtained is in crystalline. The atomic arrangement is crystalline, which is used to manufacture silicon devices. To get an idea about how is this melt and how is this ingot pulled up, let us see one video which I have taken it from YouTube. That's this ingot and that's the melt. So this ingot is gradually pulled up. This is an ingot which is pulled up from the melt. That's the melt. And that's the solid silicon which has been formed after the CZ process is over. This is called as the ingot or the boule. Right? Now next, this video was taken from YouTube titled Sand to Silicon. Right? The reference has been given in the reference slide. Now after the preparation of that ingot, which appears like a silver color cylinder, that cylinder is sawed with the help of a diamond saw, and such circular wafers have been created. Such circular wafers have been created with different diameters. Now on this circular wafer you can see some colored material. That indicates the semiconductor devices have been fabricated. The circuitry has been fabricated on this silicon wafer. On this silicon wafer. Right? Now, that was the process of creating a pure silicon from sand. Now I would like to ask you all, can you all tell me why is silicon preferred as a semiconductor material as compared to germanium and gallium arsenide? That was explained before the starting of this video. Can you recollect? Fine. So that's the answer. Can take a look at. These are the references with which the images and the video has been taken. And thank you for watching the video.